An introduction to domain and range. Look at this. X is hours worked. Y is going to be the dollars earned. So here's our equation. A person makes $12 an hour plus the $10 they get paid for showing up. We could write it as an equation like this or in functional notation. And what we need is, let's say we say, well, let's see if somebody works 3 hours, how much money they're going to make. 12 times 3 is 36, plus 10 is $46. So in functional notation, this gives you 46. So the input, the x, would be the 3, and the output, the y, or the f of x, would be 46. So check this out. X is input, y is output. X is also called the domain, and y is called the range. So how are we going to keep all this straight? It's as easy as singing the alphabet song. X comes before Y in the alphabet. I, for input, comes before O in the alphabet. And D comes before R in the alphabet. So that's how we can tie in X to the input and the domain, and Y to the output and the range. They're always in alphabetical order. Okay, so check this out. If we were to graph that line where we said a person makes $12 an hour plus they start with $10 an hour, this would be the line right here. Now, if we talk about the domain, like what values of x can you put into that line? Well, as that line is graphed, x could be anything from, wow, nice infinity sign, from negative infinity to infinity. There's no restriction on the domain, so it could belong to the entire set of real numbers. Same thing for the y. It could go from negative infinity to infinity, but hold the phone. It doesn't really make sense for us to talk about a point down here where somebody worked negative 2 hours and they lost $14. That doesn't make sense to us. So we are going to restrict the domain. We're going to tell this guy to take a hut. Go away. Come over here. Bad boy. Stay. All right. So now we're saying, well, you know what? Our domain is going to be restricted. It only makes sense to talk about hours worked that are greater than or equal to 0. And now that we've restricted the domain, we can't go left of the y-axis in the x direction, we've also restricted the range. So now the smallest value y can be on this new line is at 10. The $10 a person gets paid for showing up for a shift, and then after that they make so much money. So the range would be restricted, and it would be any y value greater than or equal to 10. So it is as simple as, remember, D comes before R in the alphabet, so domain deals with X's, which comes before Y in the alphabet. Range deals with Y's. We've restricted the domain, so therefore we've restricted the Y's. And as is true in many cases in real life, we're restricting everything to the first quadrant and just on the X and Y axis. Okay, this is a new function. This is a quadratic, and we want to talk about the domain and the range. Well, the range is easy for us to see here. The range are all the values of y that are on this graph. Do you agree the graph will never dip below 1 on the y-axis? So we would say that y's are going to be greater than or equal to 1. So what's happening to the domain? What's happening to the x values? Well, there's no restriction. We can get as big as we want. Now, there's a danger here. When we draw parabolas, a lot of times we tend to draw them just going curving up, and we think they get real narrow. But if we zoomed out for a moment, where that first part of the graph was right there, the graph just keeps getting bigger and bigger, both in the x and y direction. When we focus back in on that little part that we've started to see, we don't necessarily get that realization. But in this case, x can be any value. That graph is going to keep going upward and outward in both directions. So once again, the domain can be any value from negative infinity to infinity for x, any real number. That's the domain. Let's see. Oh, this guy. This is a log function. Now, we don't even need to know what a log function is. That's not the point. We just see this particular graph right here, and it's our job to identify the domain. Now, we're going to learn later, this is an asymptote. This line will never quite hit the y-axis. The y-axis is at x equals 0. So basically, this function, the only x values it can have are all the x's that are greater than 0, not greater than or equal to 0. It's all x's that are greater than 0. Now, meanwhile, the range would be all the y values. It can go infinitely in the negative direction, so it's going to go from negative infinity And in this case, even though it seems to be leveling off, it can still get bigger and bigger in the y direction. So there's no restriction in the y direction, so it's going to go to infinity. So the range would once again be that y could be an element of the set of real numbers. Now, let's suppose we do that. Again, we don't really need to know where these numbers come from. It's just important for us to know that one of the points that's on this graph would be this point, the point 102. So what if we said we're going to restrict the domain, or I'm sorry, the range, so it has to be at most 2. That means any part of this graph up here is no good. We're not going to be allowed to go further in the y direction. So consequently, the furthest we can go in the x direction is right there at x equals 100, because once we go past 100 in the x direction, the y's keep getting bigger than 2, and we restricted the range, the y values, to being less than or equal to 2. So that says that our x values will be 100 or less, and it's going to keep getting closer and closer to the y-axis but not quite make it there. So the interval for which we can have our domain would be right there, from 0 to 100. And it includes 100, but it doesn't include 0 because it just gets closer and closer to it. So here's a linear equation or function. X would be the inputs, y would be the outputs, the x values would be the domain, and the y values would be the range. X before Y in the alphabet, I before O, D before R, domain and range. That's in functional notation. It's also a linear function. And in this case, if we put 2 in for X, what comes out is 3. So the input of the function is the 2, the output is the 3. We said that this is the X and this is the Y. And we can say that the domain would be all the possible X values we can put in, and the range would be all the possible y values that we put in. Here we go. You might see a problem like this on the homework tonight. Find values of x for which y is less than 4. Well, the value of a function, you guys, is the y value, and it's where you are in the y direction. So y being less than 4, we go up to the to here in the y-axis, and it's right there, and it's right there. So we're talking about these parts of the graph down here. In fact, open circle, and anything down here. So, what would the x values be? What's our domain if we restrict y to being less than 4? Well, it's any of the x values coming from negative infinity, but stopping just before we get to, it would actually be negative 4 on here is the idea. So we're going to say that x can go from negative infinity to negative 4, or, and we can use this symbol for or, it's no big deal if we don't get that, that's the word or, and we can go from negative 4 to infinity, open intervals, because y, the range, was restricted as being below 4. This graph is below 4 for any value of x. Ooh, I did that wrong. Sorry, shouldn't be a negative sign there. Oopsies. So this is a plus sign. So from plus 4 to infinity, and from negative infinity to negative 4, those are the x values that would allow our y values to be true to that statement that y is less than 4. So this would be the domain. This would be describing the possible x values. So just remember, x comes before y, d before r, so domain are the x values, range are the y values, input for x, output for y. Domain are the possible x values we can use, range would be the possible y values we can use. Later in mathematics we get a little bit more sophisticated with something called a codomain, but for now we don't care. This is good enough. It'll suit us just fine.